Hey kids, let's talk about vertical stretch as a transformation. So in my original function, or my parent function, I have f of x equals x minus 2. And we're going to go ahead and make a table to see where our points will be, and then we'll also look at how to graph it. So let's say that I want to look at -1, 0, and 1. At -1, I would just plug in -1 into my x, minus 2, and I'd get -3. At 0, just plug in a 0. I'm going to be at -2. And then at 1, to figure out where that point is, just plug in a 1 to my x, minus 2, and I get a -1. All right, and let's see if these match up real quick. If I go to graph this, and I notice that this is in y equals mx plus b, I know my slope, there's an invisible 1 in front of that x, so it's 1 over 1. And then my b, or my y-intercept, it's the number behind it, is going to be a -2. So if I go to graph it, I start with my b, I go down 1, 2, put a point there, and my slope is 1 over 1. So it goes up 1, over 1, goes up 1, over 1, up 1, over 1, same thing, down 1, down 1, down 1. Let's check if these are right. At -1, it should be at -3. 1, 2, 3, yep. That checks out. At 0, it's at -2. Yes. And at 1, it should be at -1. Checks out. So the graph of my original function looks like this. Let's say we transform it to our new graph, which gets a new name, g of x. And this one is stretched by 2, or multiplied by 2. So to figure out my equation of this new one, simple substitution. G of x, or my new line, is equal to 2 times, I'm going to plug in what f of x is equal to, x minus 2. And then from here, all I need to do is distribute. So it will give me 2 times x is 2x, 2 times a -2 is -4. And this is the equation for my new line. And if I'm looking at this one, I'm going to write it up here so it looks neat. G of x equals 2x minus 4. And in this one, my slope is equal to 2 over 1 because there's an invisible 1. And then my b is equal to -4. All right. Now, let's say I wanted to plot my points to see if they add up. I'll do the same ones, -1, 0, and 1. Just like I did last time, I can plug in my value for x into x in my equation to see what my y, or my g of x, would be. So I plug in a -1, it's 2 times -1 minus 4. I should get a -6. 0 times 2 minus 4 should give me a -4, and then a 1 times 2 minus 4 should give me a -2. All right, so I've got some points, and I'll check if those add up in a second, but let me use my equation, and we'll go ahead and graph, and we'll come back to these guys. So g of x, I know my b is at -4, so I'll go down 1, 2, 3, 4. That's where I'm going to start my graph. My slope is 2 over 1, so I'm going to go up 2, over 1, up 2, over 1, up 2, over 1. Up 2 and over 1, and then backwards, it doesn't really matter. I'm going to go ahead and draw my line in, and let's see if these points that I drew match up to when I worked it out. At -1, I would have -6, so -1 goes to -1, 2, 3, 4, 5, 6. I bet it hits, though. At 0, I'd be at -4. Sure am. At 1, I'd be at -2. And that looks good. So when you're vertically stretching a line, or you're multiplying the function by any whole number, your slope is going to become steeper.